Alright, ladies and gentlemen, welcome to Unit 3 of our Accuplacer program that we set up for you, where we're going to be covering all the basics that you need to know about quadratics. And so the basics we're going to be covering in this video are multiplying binomials, including the distributive property, what that means, what binomials are, ways to multiply them. We're going to over 3 basic methods, and you're basically just going to choose whatever one you want. And then factoring, which is going to be the opposite of that, it's going to be undoing the multiplication that we had basically just done. So first off, what is a binomial? A binomial, by that prefix, is the number 2. So it is a term with 2 numbers in it. For example, we could look at the binomial 3x plus 1. That is an expression that has 2 terms. That is a binomial. It could be something much weirder. Could be like 3x squared y minus 12z. Okay, quite weird. Also a binomial. It literally just means that there are 2 things. It doesn't matter what they are. The only thing you want to be careful of is technically like 3 plus 1. That's not a binomial because it's really just the number 4. Okay, so it's really just what I should be saying is 2 things that cannot be combined into 1. Now, the distributive property is a way of multiplying across a binomial, okay? So when I see 5 times 2x plus 4, I want to think of 2x plus 4 as really just one term. So I have one term, which is 5, and the other term, which is the number 2x plus 4. And so when I am multiplying the 5 into this entire binomial. So it means everything must get multiplied by 5. And that leaves me with 10x plus 20. Okay? And it could be something much larger than that as well, where if you look down here, this is going to be 2x times all of these. Okay, so it has to be distributed basically 3 times. And so what we're going to get here is we are going to get 2x times x squared plus 2x times negative 16x plus 2x times 10. So that everything gets multiplied by 2x. Okay? So for that first one, I didn't write out this step. It was only 2 things. I can kind of keep track of that. Once I get to 3, I feel like I have to be a little bit more careful with myself. And now we multiply these. 16 times 2 is 32, so it's minus 32. X times x is x squared. And then 10 times 2x is 10x. Okay? And that's basically distributing for you. So let me look at something multiplying binomials. I want to look at this first one kind of the same way we did before. Before we had the 5 in the front, and we multiplied it to everything in the other binomial. I want to treat this x plus 1 as the 5. It's like just the number in front. Where what we did was we took it and we distributed it into both terms of the binomial. And I could really do the same thing. The distributive property works even for more complicated examples like this. So the first term I get would be my x times x plus 1. And that'd be plus this negative 4 times x plus 1. And then what I have is really just 2 examples like what we had just done, where I can distribute the x's. So I have x times x is x squared, x times 1 is x, and then I can distribute this negative 4. And so I would always distribute the negative 4. Don't just distribute the 4, because if you only distribute the 4, what you need to do is you need to keep that second part in parentheses and then distribute the negative sign. It's just, I think it's kind of a lot to keep track of. But you won't have to worry about it if you just carry the negative with the 4 all the time. So I have negative 4 times x is minus 4x. And then negative 4 times 1 is minus 4. Okay? And then I don't have to worry about parentheses. I don't have to worry about being very careful. So whenever you have that negative, just distribute the negative with it. And everything's going to be just fine. Last thing here is these 2 terms in the middle can be combined. So I have x squared plus, and then I have x minus 4x. This is really a 1x, is a good way to think about it. And 1 minus 4 is negative 3. Okay, and that's just straight using the idea of the distributive property. What most people learn, however, is a thing called FOIL, and FOIL is really just kind of an acronym to cover 4 multiplications, which are first, outer, inner, and last. Okay, so when you're multiplying first, what it means is the first number that shows up in the binomial. So in that case, it is x and x. And then, outer, I want the terms on the outside. So the x is on the far left, the -4 is on the far right. So those are my outer terms. So I have a -4 and I have an x. And then inner is kind of the opposite of that. There are 2 things in the middle, closest together. That is 1 and x. And then lastly, I'm multiplying the last terms, which are the terms that show up last in the binomial, which are 1 and -4. And then these are the things I multiply together. X times x is x squared. This is going to be plus 4x. I'm sorry. This is a -4. So it is minus 4x plus 1x minus 4. And as you see, it's exactly like what we had before. Our middle terms are in a different order, but that doesn't matter because -4 plus 1 is still -3. And we end up with the same answer as before. Now this last method is something that I didn't learn when I was going through high school, but I really like it. It's a great way of organizing your work, especially if your handwriting's not that great. And it's called the box method because you literally build a box. If you've taken biology, it's really looks a lot like making a Punnett square, if you remember that. And so what I do is I'm going to take my 2 binomials. In this case, I have x plus 1. I'm going to put it on the top of the box. And I have this binomial x minus 4. So I have an x and a minus 4. I'll put that on the sides. And my solution comes from the 4 boxes on the inside, where I generate these answers by, if I look at this top left box, that comes from multiplying the first column and the first row. Okay, so I'm just basically lining them up like this. So I have x times x is x squared. Then here in this box, I have my still first row, and then it's the second column. So I have x times 1, and that is just x. And then here I have minus 4 times x, and that is going to be minus 4x. And then lastly here, I have 1 and minus 4, and 1 times -4 is -4. And so this solution is x squared plus x minus 4x minus 4, which is exactly like what we've seen twice already by now. So it's x squared minus 3x minus 4. Okay? And I tend to like that. I think it keeps your work very well organized. I think it's very easy to follow. And when you get kind of more complicated looking binomials, what I mean by that is just like kind of just bigger numbers that are just typically slightly more annoying to work with. I think this helps out a great deal. So here we have just 3 more examples, so I want to run through those. First guy here, 3x minus 2 squared, that's not even multiplying binomials it seems, but it is. So if you just remember just squaring something, so like 3 squared is 9, but before you just jumped to your answer 9, at some point you had to have learned that when you square something, you are multiplying it by itself. So 3 squared is really 3 times 3. And so that idea extends to everything, not just like numbers. I can square binomials as well as I drop my pen and create all these stray marks all over the screen. So 3x minus 2 squared is 3x minus 2 times 3x minus 2. So it's multiplied by itself. Okay, so now if I want to do this kind of the traditional way of distributing, I want to distribute this first binomial, I'm going to distribute it to the second binomial. So that's going to give me, I'm going to have 3x times 3x minus 2, and then I have my -2 times 3x minus 2, and we're just going to distribute each one of these. So I have 3x times 3x is 9x squared. 3x times minus 2 is minus 6x. And over here, remember I said I want to distribute the negative, the whole thing. So I have negative 2 times 3x is minus 6x. And I have negative 2 times negative 2, which is plus 4. Okay? So simplifying this, our first answer is going to be 9x squared minus 12x plus 4. It's simple as that. Okay? Second one here, let's FOIL this. So if I want to FOIL, I want to do the first terms, which are the 2x and the 3x. That's going to give me 6x squared. Okay? And then I want to do the O, I want the outer terms. So the two terms on the outside are the 2x and the 3. So 2 times 3 is 6, so this is going to be plus 6x. And that's all set. And then I, inner, so I want to multiply the two inside terms. So I have 1 times 3x, which is just 3x. And we're all set there. And then L, our last terms, are 1 and 3. So this is plus 1 times 3 is 3. And so our final answer here is going to be 6x squared. 3 plus 6 is 9. So this is 9x plus 3. Okay, and that looks pretty good. Last one, let's go back to the box method that I really like. And these are a little bit bigger numbers. Maybe we should just kind of get in here a little bit. So one of my binomials is 5x minus 2. So we'll set that up there. Our other binomial is 3x minus 7, or plus 7. So I'll have 3x plus 7. And now we're just going to fill in this box. So I have 3x times 5x. 3 times 5 is 15. X times x is x squared. Other box over here, 3x times minus 2 is minus 6x. Bottom left, 7 times 5x is 35x. And then 7 times minus 2 is negative 14. So our answer here should be the sum of 15x squared minus 6x plus 35x minus 14. And so we have our middle terms here that we can combine. And we simplify this to 15x squared plus 29x minus 14. Okay, so that's all three of our examples, or all three of our methods at work. Alright, so I just did 3. I would like you to do 3 now. These are 3 practice problems for you. You don't have to use one of each method. Use whatever method you find most comfortable, or whatever method you want to practice more. First 2, you are just distributing and coming up with an answer, and the third one is a multiple choice. So you don't necessarily have to do all the work. Just do enough work until you can get to the answer. So please pause the video, double check your notes, try these, because I'm not going to do any of the work. I'm just going to give you the answer in a couple of seconds. So please do that now. Alright, so for our first practice question up here, we should come up with the simplified answer 6x squared minus 7x minus 3. Our second answer down here should come to 7x squared plus 30x plus 8. And down here you should have hopefully rewritten 2x minus 5 squared as 2x minus 5 times 2x minus 5, and then successfully gotten your way to C. Okay? Most common answer that I would like to try to make sure we are avoiding. I'm sure if you got B or D, you made a tiny mistake somewhere, so just double check that. But the answer we really don't want is A. That's a very common mistake where when people look at the term or at this expression given to you like this, they just want to square everything. So you have 2x squared, which is 4x squared, and then negative 5 squared is positive 25, and you come up with the answer of A. Please, please, please do not do that. I assure you that if something like number 3 shows up on the Accuplacer, there will be a wrong answer like A in there, because it's a very, very common mistake. So whenever you see something squared, always write it out like that, and then go through, make the box, do the foiling, whatever you need to do. But please, please, please do not be so hasty as to come up with A. Okay, so now we want to talk about factoring, which is really kind of working backwards from what we were just doing. The most basic thing that we're going to be doing with factoring is something called factoring out a greatest common factor. And that is going to be looking at a expression with multiple terms in it and seeing if they have anything in common, any numbers in common as far as factors. And so what I mean by that is, for this example, let's look at all of the factors of 6x squared. So 6 is 3 times 2. And then x squared is x times x. Okay, so that's really however much I could break down 6x squared. That's pretty much all I can do. 3x is much simpler because there is nothing else going on. It's just 3 and x. And so you want to try to get in the habit of looking for things that they have in common. So maybe even without even multiplying or without even doing this step, I want to look at 6 and 3 and say, well, they have a factor of 3 in common. And x squared and x, they have a factor of x in common. So basically whatever they have in common is what I'm going to try to factor out, which basically means I'm going to divide it out of each of the terms and put it in front of parentheses as if we were about to distribute it. So I have my 3x there. And so what am I left with when I factor a 3x out of 6x squared? Well, look here. I'm left with a 2 and an x. So that is what goes here. And then, what am I left with when I factor a 3x out of 3x? Your first instinct might be 0. However, you want to think that we want to eventually distribute this. We'd like to be able to distribute it and come back to our original answer. So it'd be 3x times what gives me 3x? And the answer is 1. So anything times 1 is just itself. So 3x can be rewritten as 3x times 1. And that's what I'm left with. So 3x divided by 3x is 1. And to make sure that you are right, the best way to check that is to really do that distributing, like what we just done. So this is our answer for the factoring. And if I wanted to double check it, I would check, is 3x times 2x plus 1 really equal to 6x squared plus 3x? And you say, well, absolutely is. That's what we started with, so we are good to go. So here's a much crazier example, just to show you how complicated these can get. If I want to factor out the greatest common factor of these 3 terms, I need it to be common in all 3. So not just common in 2 of them. I want all 3 of them. And let's do this one step at a time. Let us first look at the numbers. So I have 8, 2, and 10. Well, I know 2 is just itself. 2 is just 2. There's nothing fancy there. 10 is 5 times 2. And so I already see that common factor of 2 between those. So if 8 also has a common factor of 2, then it's common with all 3 of them, and I can factor it out. And in fact, 8 is 4 times 2. So now we can very easily factor 2 out of everything. So I'm going to actually do that right now. I'm going to know that my greatest common factor is going to have a 2. Okay? Now, looking at the x's, x cubed is x times x times x. X squared is x times x. And x to the 5th is x times x times x times x times x. So you want to look at those and say, well, what do they have in common? And what they have in common is that they all have at least 2 x's. So I'm going to take out 2 x's, or an x squared, from everything. And then lastly, we have all these y's. So y squared is y times y. Y is just itself. So what do they have in common? They all have 1y in common. So that's what I'm going to factor out. Okay? And now we want to look at what do we have left. So when I look at this first term, 8x cubed y squared, when I factor out a 2, I'm left with a 4. When I factor out an x squared, I'm left with just 1x. And when I factor out a y, I'm left with there just being 1y. Okay, and that's my first term. Now my second term, when I factor out a 2, all I'm left with is a 1. I don't have anything else left. There's nothing there. When I factor out 2 x's, all I'm left with is a 1, because those are my 2 x's. When I factor out a y, all I'm left with is 1. So there's nothing left in there except for 1. I've already factored out a 2, an x squared, and a y. There's nothing more I can take out. And then lastly, when I factor a 2 out of 10, I'm left with 5. When I take 2 x's out of x to the 5th, I'm left with x cubed. And when I factor 1y out of 1y, all my y's are gone. So this should be my answer. Okay? And there's a lot of numbers flying around, so there's really only one way to find out, and that is to check it. So that is 2x squared times y. Is that going to ultimately give me my answer? Plus 1 plus 5x cubed. Distribute, distribute, distribute. So I have 2 times 4 is 8. X squared times x is x cubed. Y times y is y squared. 1 times this is just itself. 2x squared y. 2 times 5 is 10. X squared times x cubed is x to the 5th. Y. And we check, we say, hey, when I distribute, is what I have here the same thing as what I started with? The answer is yes, and then you know for a fact that you have factored this out correctly. So please always double check your work. The beginning part of the Accuplacer is so few questions, such a small amount of questions, that really getting one wrong because you made a small mistake is a very bad idea. Very bad idea. So please, please, please take the time, double check all of your work by checking these factoring, by distributing, and making sure that you're where you need to be. Alright, now factoring quadratics can be rather difficult. So now what we see here is that I have x squared plus 3x plus 2. They don't have anything in common among all three of them, so I cannot factor out a greatest common factor. However, these quadratics are going to be factorable. Now before we talk about that, I just want to quickly kind of mention or go back to looking at kind of the foiling or the distributing that we had done before. So let's look at this. So if I were to kind of multiply those two terms, let's just FOIL it. It'll go faster. So FOIL first, I get x times x is x squared. Outer, I get 2x. Inside, I get 3x. And outside, I get 6. Okay, so I'm going to look at this relationship here. So I had a 3 here and a 2 here. I ended up with a 6 on the outside because that's where I get 3 times 2. Okay? And then in the middle, this whole thing is going to become 5x. And that 5 is really 3 plus 2. Okay? So a generalization that can be made is when you have a 1x squared out front, that means that this middle term is always going to, or these two binomials are always going to be x times x. You can draw this conclusion where this last term of the 6 is the product of your two terms, or the two constants on the inside of the binomials. And then that middle term, this 5x, is the sum from the addition of the 2 and the 3. Okay? And so looking at this example that we have in the center of the page, if I kind of extend that, I have just an x squared. Then I am trying to essentially look for things that will fill these two binomials. And this will only work when I have a 1x squared in the front, because this will always be x and x. Okay? So I want to look at the end here at the 2. I want things that multiply to 2, which are 2 times 1 and negative 2 times negative 1. That's really it. Nice and small. And I want to look for something in this list that are going to add to 3. That's going to get me to 3x. And that would be this top one, which is just positive 2 and positive 1. So this should factor into x plus 2 times x plus 1. And we could always check that by distributing. And you are welcome to do that to double check that that is correct. But that's where we are, and that's good. A little bit harder of an example is something where we end up with a negative number. Those become a little bit more annoying. So I want things that multiply to negative 10. So it's always good to make a little list. So that's like 1 times negative 10. That is negative 1 times positive 10. That is 2 times negative 5. That is negative 2 times positive 5. And I think I have exhausted all of my options. So that's the multiplying part. For the adding, I want these terms to add to negative 3. Okay? Now, 1 and negative 10 is negative 9. That's no good. Negative 1 and 10 is 9. That's no good. 2 and negative 5, those add to negative 3. Okay? So all signs point to, because this is a 1x squared, me being able to factor this using a positive 2 and a negative 5. Okay? So I would definitely distribute those as well, make sure they work. But I think we are on a good pace for that. Alright, so here's some more practice for you. I'd like you to factor these first two terms up here, which means we are looking for the binomials. What's good is that these are both 1x squared, so you know, I'll give you this part, they both start with x's in the front. So I want you to try those, and then the distributing, a little refresher on distributing down at the bottom. There's a reason for that. So please stop this right now, pause the video, and work on these 5, and I'll come back and give you the answers in a second. Okay, so the answers for these, for number 1, we're looking for two numbers that multiply to positive 5, but add to negative 6. And you can struggle with that a little bit, but if I multiply two negatives, I will get a positive number. So I end up with a minus 5 and a minus 1. And those multiply to positive 5 and they add to negative 6. Now if you had x minus 1 times x minus 5, that is equally correct. The order really doesn't matter. For our second one here, I need two numbers that multiply to negative 12, but add to negative 4. And our result there is going to be minus 6 and then a plus 2. Okay, so the order doesn't matter. It could be x plus 2, x minus 6. However, the signs absolutely do matter. So you cannot have x plus 6, x minus 2. If you had that, that is incorrect. Your middle term would end up being a positive 4x. Now on the bottom, hopefully you saw something weird happening on each one of these, where the middle terms are actually adding to 0, which is strange. And our terms, so these end up being x squared minus 9. This becomes 4x squared minus 25. And this last one becomes x squared minus 49. And so none of them have x terms, which is kind of weird. But let's look at why. So the reason that none of those had middle terms was because they were something called conjugate pairs. Okay? And what a conjugate pair is listed right here. They're basically the same two terms, AB, AB, but one is positive and one is negative. And so what happens when you distribute this, you get A times A, which is A squared. You get A times negative B, which is minus AB. You get B times A, which is positive AB. And then b times negative b is negative b squared. So no matter what it looks like, these middle terms will always, always, always add to 0. And it leads to a very, very useful shortcut in factoring, which is recognizing this, the solution, which is the difference of perfect squares, which basically just means you have a perfect square minus a perfect square. You will always be able to factor it into its two square roots, and then one has a plus, one has a minus, into these conjugate pairs. Okay? So looking at this first one, I have x squared minus 16. I know that that is the difference of perfect squares, because my first term is x squared, which is x times x, My second term is 16, which is a perfect square of 4 times 4. And so they should factor into the conjugate pair, x plus 4, x minus 4. Okay? Cruising right along, number 2, these are actually different than perfect squares as well. X squared is x times x. 1 is 1 times 1. And then plus minus, those are a conjugate pair. Number 3, these are a different perfect squares as well. 4x squared is 2x times 2x. 9 is 3 times 3. And so this will factor into the conjugate pair, 2x plus 3, 2x minus 3. And then last but not least, we have x squared plus 100. X squared is a perfect square of x times x. 100 is a perfect square of 10 times 10. And so these should be the conjugate pair, x plus 10, x minus 10, but it is not. Why is it not? Why is it not? This is all wrong. This is all wrong. Why? Look at here. This is the difference perfect squares. X squared, a squared minus b squared, minus 16, minus 1, minus 9, plus 100. Okay? So I made a mistake there of just putting my head down and just barreling through because I had 4 things that were like exactly the same, so I just went on autopilot. You got to be very, very careful to not do that. Hopefully you caught that before I did. So this is the sum of perfect squares, x squared plus 100. There's actually no way to factor that, so this is actually not factorable. That actually has no answer, okay? So you want to be very, very careful that you are not just recognizing the 2 perfect squares, but that is the difference of perfect squares. So it must be subtraction. Okay, so this is the last thing we're going to do today, just some last practice for you to go through. So same drill. Please pause the video and try these, and I'll be back in 2 seconds with the answer for you. Okay, so number 1 here, we have a difference of perfect squares. X squared is x times x. 100 is 10 times 10. This one is plus 10 minus 10. This one is actually the subtraction. So it's kind of like what we wanted to do on the previous one, but couldn't because it was x squared plus 100. Number 2, I think this actually showed up earlier somewhere today. This is x plus 7, x minus 7. Number 3, these are perfect squares as well. So this is 2x and 2x. And then 121 is 11 squared. So this becomes the conjugate pair 2x plus 11, 2x minus 11. And then lastly, we have this conjugate pair of 3x and 4. So we have 3x plus 4, 3x minus 4. Okay. So that's it for the video. Please check online for the practice, and good luck on that and the post quiz.